Let's take a look at this problem from section 11-3. A study of seatbelt users and non-users yielded the randomly selected sample data summarized in the given table. Um, the tester claimed that the amount of smoking is independent of seatbelt use. A plausible theory is that people who smoke more are less concerned about their health and safety and therefore are less inclined to wear seatbelts. So is this theory supported by the sample? Okay, so this is clearly a test for independence because test the claim that the amount of smoking is independent of seatbelt. And so we're going to set up our null and our alternative hypothesis by saying smoking is independent of wearing seatbelts, which is what the claim is. The alternative hypothesis would just be the opposite, which is not independent. And then let's remember that the null hypothesis was the original claim. There is no alpha, so we will assume 0.05 for our significance level. And then we're pretty much ready to use our chi-square test from our calculator. And this is a test for independence. Our test will require the use of a matrix. So what we need to do is we need to input this data in the matrix. Now the data that's important would be this data over here, and we have to identify what the size of this matrix is. So we count the number of rows first and then the number of columns. So there are 2 rows and then there are 1, 2, 3, 4 columns. So we're going to have a 2 by 4 matrix. We need to input this data in our matrix, so we're going to go to second function and matrix. Actually, there's some calculators that might have a different button combination to get your matrix. You'll get the screen and we want to go to edit because we want to edit our matrix. Now we're going to use matrix A, and then the calculator will also make use of matrix B, but we don't have to mess with that. We only have to edit one matrix, and that will be matrix A. So I'm going to go ahead and press enter, and then the first thing I want to do is resolve the size of my matrix. I have a 2 by 2 right now, so I can press 2, and then you can press right arrow or enter, and I press enter to get to the next column number. So for this I'll press 4, and when I press enter this will expand to this. Now the calculator's screen size is only so big, so if it's going to be a little bit too wide, just remember that there's going to be space here to put our 4th column. Alright, so we're going to put 175 in for the first one, and so I just type 175 and I can just press enter. And then this will move me to my next one, which is 20, enter, 42, enter, 6, enter. So that takes care of my first row. Now I'm my second row, first column, 149, and then 17, 41, and 9. And then make sure you press enter on the last one, otherwise it will remain the previous number that was there. Okay, so now that my matrix is ready, I'm going to second function and quit out of there, and then I'm going to run my stat test. So I'm going to get my stat, go over to test, and then if I scroll up it'll get there sooner, and I want to get to the chi-square test. So this chi-square test, I'll press enter, and if you don't change this it'll remain the same. And the default is to have the observed matrix in A and the expected matrix in B. Again, we didn't mess with the expected matrix in B, but we don't have to because the calculator will take care of that. So I'm going to go ahead and just calculate. And with a chi-square test, we have a test statistic of 1.358, which is really small, and so our p-value is expected to be pretty big. And then we'll end up with our conclusion. So our test statistic, again, we'll call it TS, and it's a chi-square value, and that's equal to 1.358, and our p-value is 0.715. So clearly our p-value is bigger than our significance level. So we're ready to make decisions and conclusions. First, our decision is to fail to reject the null hypothesis. And we can state the reason that the p-value is bigger than the significance level. And then our conclusion, based on our claim, we failed to reject, so we were not able to reject the null hypothesis. So, and since our null hypothesis is the claim, we'll say we're not enough evidence to reject the claim, and then we'll look for the claim. The amount of smoking is independent of seatbelt use. So unable to reject the claim that the amount of smoking is independent of seatbelt use. Alright, so that's our formal conclusion in non-technical terms, and let's see if we can answer this follow-up question. There's a theory that says that the more people who smoke, the less concerned they are about their seatbelt, and the question is that true? So if it's not independent, it looks like it's we're unable to reject the claim, so it seems like it is independent. So because it's independent, it doesn't seem like the amount of cigarette dictates the fact that they're going to wear less seatbelt, or more of a chance of wearing seatbelt, or less of a chance of wearing seatbelt. So it doesn't look like this theory is supported. So we can state that. And then maybe in other words, we can also say that the people who smoke don't seem to be less concerned, more or less concerned about their safety compared to people who don't smoke. So we can state it like this, or state it any other way, just to say that it doesn't seem like it's dependent. It doesn't seem like wearing seatbelts is dependent on smoking. Alright, so that's it. It's our chi-square test does everything else for us. Okay, so I hope that helps.